So we created some of our very first tensor. An error. Resource variable object does not support item assignment. Okay, what if we go back to this documentation? So TF variable, they've created one here, similar to how we've created ours, but they've only got one element, which is a scalar. And they they've used v.assign. Alright, and then it's changed from 1 dot to 2 dots. So what if we tried that? So let's come back here. How about we try dot assign? Alright. Changeable tensor and the 0th element dot assign, and then we want to change it to 7. Just 7. What do you think will come out here? Let's have a look. Ooh, wonderful. There we go. Alright. So, how about if we tried to change a value in our TF constant tensor, or our unchangeable tensor? Now, let's try change our unchangeable tensor. Let's just try to do the same change. Make it simple. Unchangeable tensor and 0th element. Well, first we'll index it as well, just to check. Same output here, numpy 10. And what if we go equals 7? What happens there? Oh, object is not a support item assignment. Okay, so similar error to what we got up here. Oh, that's okay, we know the fix. We can just go assign 7. We'll get that bracket back up on there. And then we'll check out the unchangeable tensor. Oh, another attribute error. TensorFlow Python Framework ops eager tensor. Object has no attribute assign. So what do you think is going on here? We've got a changeable tensor, which is a TF variable, and an unchangeable tensor. Where our TF variable is changeable using the assign attribute, whereas our unchangeable tensor, which kind of makes sense if its name, doesn't change even when we use the assign. Now you might be wondering, why can we change some tensors and why can't we change others? Well, it comes down to behind the scenes. When we're writing neural network code, we might want some tensors for their values to be changed, whereas we might want some tensors for their values not to be changed. So, there's a variable tensor, and there's a constant tensor. Now, again, we're going to reiterate the fact that a lot of the times you won't have to make the decision between using a variable tensor or a constant tensor. The decision will be made for you behind the scenes when TensorFlow creates tensors for your neural networks. But we're going to get very hands-on with that. And so speaking of TensorFlow creating tensors for our neural networks, let's have a look in the next video, which is going to be creating random tensors. Woohoo! It's exciting. I'll see you then. So we've seen how to make tensors with TF constant and TF variable, let's see how we might create random tensors. So actually I'll make that a size 3 heading. And I just want you to, I'll point out something here that I've added to the last little section of code that we run. And this is going to be a trend throughout the course, is that if there's like a little tidbit that you should be aware of. I'm going to use this key emoji and add a little note there. So rarely in practice will you need to decide whether to use TF constant or TF variable to create tensors, as TensorFlow does this for you. However, if in doubt, use TF constant and change it later if you need. So that's a little tidbit going forward. So if you ever see the key emoji with something coming after it throughout this entire course, throughout any of the notebooks that you use and the GitHub and whatnot, that's just a little tidbit to take note of for later. But let's get hands-on creating random tensors. So random tensors are tensors of some arbitrary size which contain random numbers. You might be wondering, why on earth would I ever want to create a tensor? Where's an example of one of our tensors? Like this, filled with random numbers. And I have a great illustration to show you. So let's go to our keynote slide here. This is what neural networks use to initialize their weights, in other words, the patterns, that they're trying to learn in our data. So if we imagine this diagram here, we have our inputs. Say we had pictures of food that we're trying to classify into ramen or spaghetti. We might turn that into tensors. We'll see how to do this in a future project. So this is our numerical encoding of our images. Then we might pass that numerical encoding to the input layer of our neural network. Then our neural network might learn representations which are called patterns, features, or weights, then output those representation outputs, and then we convert them into something that we can understand rather than just tensors. But where does the neural network get these representations from? Well, in the beginning, it's going to initialize itself. Initialize is another common word you'll hear in deep learning. Initialize just means start with. Initialize its weights or the patterns it knows with random weights or random tensors. So this would be a random tensor to begin with. And then, as it sees different examples of photos of ramen and spaghetti, it's going to update its representation outputs. In other words, start to tweak these random weights and patterns to better suit our data. If we go through again, we're going to repeat this cycle with more and more examples. So if we imagine the flow here, we've got images, we numerically encode them, our neural network initializes itself with random weights, in other words, a random tensor, and then as we start to show it more examples of what photos of ramen and spaghetti look like, it starts to tweak these random weights to be better adjusted to the patterns that are in our images so that our representation outputs line up better with our desired labeled outputs. So maybe in the beginning it gets these images, these two here, wrong, but then as it keeps going, it starts to learn them and it starts to get them right, like these two here. So let's go back. That's a brief overview of how a neural network learns, but that's the context of where you might use a random tensor. So how might we create a random tensor? So let's create two random but the same tensors. Now, before we even write any code, we go how to create random tensors with TensorFlow. TensorFlow.random.uniform. Wonderful. So we could go through that, or we could start to write the code. Seriously, when I don't know something, that is the type of search that I will put into Google and look up. As much as I'm trying to teach you TensorFlow itself, I'm trying to teach you how to search for answers to solve your own problems. Because at the end of the day, I can only show you so much. But let's create random one, which is going to be tf. Random generator from seed 42. What is a seed? So the set seed for reproducibility. So we'll see what the random seed means in a minute. If you've ever used NumPy, it's very similar to NumPy's random seed. So random one equals random one dot normal. I want you to guess if we put in the shape parameter here. So if we come here, go to this first one, random uniform, shape. We've got random normal, shape, 3, 2. What shape will our tensor be if we were to press Shift and Enter? TF tensor, shape 3, 2. Now, we've used normal here, but this is uniform. What's the difference? So output random values from a uniform distribution. What is a uniform distribution? Here we go. Wolfram.com. A uniform distribution, sometimes also known as a rectangular distribution, is a distribution that has constant probability. Whoa. So oftentimes when I read stuff like this, it takes me a long time to grasp it. If you're the same, I want you to realize that that's not necessarily a problem. It's because in practice, when you're writing these random tensors, again, a lot of it is done behind the scenes for you. What I want you to get familiar with is writing as much code as possible, like we've done here, and then starting to see what the outputs of that code is. The more and more you do it, the more familiar you will get with it. So let's create another one. Maybe we'll come up here, random 2 equals tf random generator from seed 42, random 2 equals random 2 dot normal shape equals 3, 2. You might be wondering, Daniel, you've just looked up uniform and you haven't done anything with it. So what is normal? Well, great question. So what is TensorFlow random normal? tf.random.normal. Outputs random values from a normal distribution. Okay, tf random normal shape. All right. What is a normal distribution? See how we're sort of just pulling the thread here? This is what I do with any problem that I'm working on. A function that represents the distribution of many random variables as a symmetric bell-shaped graph images. Okay, so that's the normal distribution. Again, you can look into this more if you want, but we're going to be practicing writing more random tensors. So, are they equal? Random 1, random random 2. And now we'll use this equality operator to compare the two. Random 1 equals random 2. Are these equal? Let's have a look. What do you think? Are they going to be equal? Oh, yes we do. We have random 1, remember these come out in order, and then random 2. And so they've come from a normal distribution. This equality operator is this last one here, which is saying that the top left element is matching this top left element, true. The top right is matching here and here, so that comes out true. And then we get the same for the rest of the array. Beautiful. So I want you to know that the random tensors here, although these appear pretty random, these numbers, they're actually pseudo-random numbers. So they appear as random, but they really aren't. That's because we've set the seed here. Setting the seed, but they really aren't. That's because we've set this. Although these appear pretty random, these numbers, they're actually pseudo-random numbers. So they appear as random, but they really aren't. That's because we've set the seed here. Setting the seed says something along the lines of, hey, TensorFlow, create me some random numbers, but flavor them with x, where x is the seed. So what do you think would happen if we changed the random seed to my favorite number, which is 7? I have a dog called 7. She's beautiful. What do you think will happen here? We get some slightly different random outputs, but they're still the same between random 1 and random 2. Okay, we've seen how to briefly create some random tensors, and I mean, if we go how to create random tensors with TensorFlow, there's going to be a whole bunch of more different ways. But if we had our random tensors, or if we had just non-random tensors, what if we wanted to shuffle the order that the variables appear in here? Let's have a look at that in the next video. In the last video, so we've seen how to make tensors with TF constant and TF variable. Let's see how we might create we checked out how we can create some random tensors, and we tied that back to the concept of when a neural network starts to learn, it wants to learn patterns in some sort of data set. It starts off with random patterns and then slowly adjusts them as it continually learns on more and more examples. So if we come back here in this video, let's see how we might shuffle the order of, what should we call it, elements in a tensor. Alright. Why would you want to shuffle the order of elements in a tensor? Let's go back to our example here. So let's say we were working on a food image classification problem, and we had 15,000 images of ramen and spaghetti. Let's keep it nice and simple. And the first 10,000 images were all of ramen. And the last 5,000 images in our folder, like they're in order, so the first 10,000 are all of ramen, and the last 5,000 are all of spaghetti. Now, this order could affect how our neural network learns. So if it goes through these images in order, it might start to adjust its random weights, too much so to the images of ramen, because if it goes through 10,000 images of ramen, it's like, okay, well, I only have to learn what ramen looks like. It doesn't know that it has to also learn what spaghetti looks like until it goes to the last 5,000 images. So instead, it might be a good idea to just mix up all the images in our folder so that they basically have no order at all. So we might have ramen, 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 spaghetti, spaghetti, ramen, spaghetti, ramen, spaghetti, ramen. And then the neural network can be fed different examples of different images and adjust its internal patterns or weights, the random tensors it got initialized with, to learn both types of images at the same time. Let's go back to our Colab notebook and let's see how we might shuffle a tensor. So we go shuffle a tensor. So this is valuable for when you want to shuffle your data. So the inherent order doesn't affect learning. Now, what we might do is create another tensor. We'll get some practice creating tensors here. Not shuffled equals TF constant. And then we might just create a very similar tensor to what we created above, 10, 7, my favorite combination of numbers, my favorite poker hand. And there we go, and 2, 5, why not? There we go. So a little test here is if we did not shuffled dot ndim, what do you think that's going to output? Well, let's find out. 2. Okay. Why might that be? Not shuffled. Because it has a shape of 3, 2. So there's 2 elements in the shape attribute. Beautiful. So let's see how we'll shuffle this. Maybe if we just go how to shuffle a tensor in TensorFlow. tf.random.shuffle. Okay, beautiful. So randomly shuffles a tensor along its first dimension. tf random shuffle seed equals none, value. Okay, dimension. tf random shuffle seed equals none, value. Okay, there's an example output. Let's try it out. So the value, what's value? This is how I read the documentation. So the arguments. So the value is a tensor to be shuffled. That's what we want. And the seed could be a Python integer used to create a random seed for the distribution. C random.set seed for behavior. Okay, let's get hands on with this. So shuffle our non-shuffled tensor. So let's go tf.random.shuffle. And then, oh, look at that, the doc string appears for us. If we wanted that on our own, we could press Command-Shift-Space. So I'll come up. In Colab, it automatically, sometimes the doc string just automatically comes up if you're just chilling in here. But we can press Shift, Command-Space, or if you're on Windows, Shift, Control-Space. There we go. We just get the exact information from the TensorFlow documentation. How handy is that? So let's pass it. What does it take? Args, value, a tensor to be shuffled. Let's pass it in, not shuffled. Okay. What do you think is going to happen here? Well, let's find out together. Boom! Okay, look at that order there. So if we get 10, 7, 3, 4, 2, 5, and now the order's changed up here. Okay, so there's still 2, 5, still 10, 7, still 3, 4. Okay, what it's done is if we come back up here, randomly shuffles a tensor along its first dimension. So, if we look at not shuffled, it's got a dimension of 3 times 2, which is 1, 2, 3 elements. So it shuffled it along its first dimension, which means it shuffled it along this dimension here, so the 3, 1, 2, 3. So it means that the elements in the second dimension, which is 10, 7, 3, 4, 2, 5, have stayed in order, but they've been shuffled around. So 10, 7 was at the top, but now it's in the middle. 3, 4 was in the middle, but now it's at the bottom. And 2, 5 was at the bottom, but now it's at the top. Okay, now what if we were to run this cell again? I want you to take note. Actually, let's copy this. So copy that, and I'm going to add another code cell here. I'm going to run this cell here. Okay, 10, 7, 3, 4, 2, 5. Same as before, but what if we run it again? 10, 7, 2, 5, 3, 4. Okay, different order. Notice how every time I run it, it's a different order. And I mean, there's only 3 elements here, so sometimes you're going to get the same. Now, what if we were to put seed equals 42? So if we come here, a Python integer, seed used to create random seed for the distribution. What happens if we do that? Seed equals 42. Seed equals 42. We get still different results. So what if we did tf.random.set seed 42? Okay, 10, 7, 3, 4, 2, 5. 10, 7, 3, 4, 2, 5. 10, 7, 3, 4, 2, 5. Okay, 10, 7, 3, 4, 2, 5. Now we're getting the same order. That's quite confusing. So how might we figure this out? If we come back here, seed, we set that to 42, but we didn't get the same results. So seed, it says here, used to create a random seed for the distribution, C, TF random seed for behavior. Okay, so let's click on that. Here we're kind of pulling the thread of what our problem is. We're trying to figure out how to set random seeds or random operations in TensorFlow. So operations that rely on a random seed actually derive it from 2 seeds, the global and operation level seeds. So I think this one might be the global level seed, and this one might be the operation level seed because it's a part of an operation here. That's my intuition. Now, its interaction with operation level seeds is as follows. Okay, so we've got 4 rules here. I'm not going to read these out, but what I want to do is put this here, and I want you to start exploring or start practicing. So this is your homework for this lesson, so this one can be here. If you see this symbol here, this means exercise. So exercise, we're going to go read through TensorFlow documentation on random seed generation and practice writing 5 random tensors and shuffle them. That's your takeaway for your homework for this lesson. It's alright, if you want to skip over that and just go straight to the next video, you can. But to really understand the concept of TensorFlow creating tensors, just go through and try and create maybe 5 different tensors here with tensor code, with TF constant, then shuffle them, then try to get the reproducible shuffled order using TF random set seed and a combination of seed, and then figure out, just see what happens. If in doubt, run the code. You can't break it, so have a practice of that, and I'll see you in the next video. We'll see a few other ways to make tensors.